Today, we are going to be walking through the steps of creating a database and a code book. So I've uploaded a couple documents in Canvas. One is just the Word doc of the code book. That should look like this. And basically what a code book includes is it includes the names of the variables, the variable labels, the type of variable, and the range of scores for that variable. Okay, so essentially why the variable name is different than the variable label is that a lot of times in your databases, you want to come up with and create abbreviations for the variables. So for instance, MBI1 refers to the first item on Maslow's burnout inventory, which is I feel emotionally drained by my studies. Now, it's a lot easier to create a name, an abbreviated name, instead of using a very long label in your database. Now, what I just brought up was the actual database that I created for you guys with your burnout inventory data. And here at the top, this is called a header row in Excel. You have the names of the variables, MBI1 through 16. And then you have the categorical demographic data that I've shared with you as well. So here, basically, to kind of walk you through a little bit about the database, here at the top in the columns, you have your variables. But then each row, so rows 2 through 25, represent each one of your individual data that you have provided. And basically, where rows and columns meet, such as right here, I've identified B2. This is referred to as a cell in Excel. Okay, so skipping back over to the code book, we have our variable names, we have our variable labels, we have the type, and basically there's two broad types of variables that we are concerned with. Those are continuous, often referred to as well as numeric, and categorical. Okay, and here for the range, because the MBI is based on a 7-point Likert scale frequency, we indicate that the range of scores for the individual MBI items is from 1, which I believe is rarely, to 7, which I believe is all the time. Okay, and then down here you've probably noticed a bunch of stuff that's written in a language that doesn't really make any sense. This is basically SPSS syntax. So what I am going to walk us through today are the steps to transporting data out of Qualtrics into SPSS, doing some quick cleaning in SPSS, and then downloading that clean data file into an Excel spreadsheet that looks very similar to this. Now, why I'm using SPSS to clean the data is that it's a lot simpler to clean in SPSS than it is in Excel. And even though we're going to be doing the majority of our analyses in Excel, I did want to give you pretty minimal exposure to SPSS. And what's really important in this process, in this video, is really the steps that somebody takes to clean data. Irrespective of whichever program or software you're using, the cleaning steps are generally the same. Okay, so let's dig into this. Now, here, because I use Qualtrics to administer the survey, I'm going to bring up Qualtrics. I'm going to click on our MBI survey, and I'm using the face-to-face time students as an example. Next week I'll use the hybrid data students or part-time students data as an example. But here what we want to go to is data analysis. And then we want to export our data. And it gives us a number of different options, either an Excel sheet where we indicate whether we want to use the numeric values on those Likert scales or the basically the string data, which is the actual words like rarely or all the time. So if we were going to download this straight into Excel, we'd want to use the numeric values. But for this instructional video, I am going to download it into SPSS. Now this is going to take a brief moment while I bring up our data set here. Thank you for your patience. Okay, so to those of you who are familiar with SPSS, SPSS gives you two viewing options. It gives you the variable view, which is essentially your code book. So it gives you the names of your variables, the types, and it gives you the label. And it also gives you the values. So instead of in our code book where we list the range, this gives you the actual values. And you can click on and see that 1 means never and 7 means every day. And then there's also this prefer not to answer choice that was embedded. So the values tell you what basically the numeric numbers mean for each one of the variables. And SPSS basically assigns generic names for the variables, such as like question 1, -1, 2, etc. We're going to go through and clean this all up. And then, apart from the variable view, there is the data view. And these are the actual data. And from here, we can see that there are 24 responses. And as you scroll to the right, these are basically the scores on the burnout inventory. Now, to go about cleaning this data so that you can create a simple, clean data sheet, there are a number of different ways to do this, but I prefer using syntax. So I'm going to open up my syntax file that I created a couple days ago. Open. Okay, here it is. And basically what I'm going to do is go through and follow all these steps to clean our data up. So to start, instead of having variable names such as Q1-1 through Q1-16, I want to label these as the MBI1 to MBI16. So basically you want to rename variables where Q1-1 you want to now equal MBI1 and so on. And you write this up and you select this block and you hit this green play button, and this is your output, which basically tells you what you did. And when we go back to our data set, now we can see that the MBI1 is now referred to by our created name through 16. Good. Now, for whatever reason, the variable labels in our SPSS data file have this click to write the question text before our variable labels. To clean that up and just retain the items, I'm going to basically indicate that we want new variable labels for each one of our 16 items, and these are what we want the labels to be. Going to select that all and hit the Run button. There we go. Now our variable labels are what we want them to be. And then, now we talked a little bit about this in class, but what I wanted to do was make sure that there were no individuals that could potentially be connected to their burnout inventory data. And in order to do this, we want to keep the groups on the demographic variables of age, race, and gender to 5 or more people. And the way to assess this is to look at the frequencies. Now in SPSS syntax, you can either write out frequencies or write an abbreviation of freq_vars for the 4 demographic items that we included in the survey. So when we look, we can see that there are less than 5 individuals in a number of our different race categories, as well as in our age and gender categories. So in order to basically manipulate or clean the data so that the racial groups all have at least 5 individuals, we have to do a recode to where we're basically merging groups of people by race and ethnicity. Now, for this example, because there's 5 African American respondents, more than 5, we can keep that group. And the same with persons identifying as being either white or Caucasian. So the other groups, Asian, Hispanic, other, and prefer not to answer, are all going to get collapsed into a 3rd category. And the way to do that in SPSS is a recode command, where we're basically recoding question 2, which is race. And what I'm going to do is view both the value labels and the value name. So here we want what was 1 for this race variable to stay 1, and then 2, 3, 6, and 7 we're combining, so we're calling all of them 2, so 2 equals 2, 3 equals 2, 6 equals 2, and 7 equals 2, and then we're retaining the white Caucasian group into our 3rd category, so 5 equals 3, into a new variable called race. So I'm going to select this, run it. And here you always want to double check your work to make sure the code or transformation worked as planned. So here we can see the African Americans still have 7 as they initially did here. Caucasians still have 11. And then the other group, Asian, Hispanic, other, and PNA or prefer not to answer has 6. 3, 4, 5, 6, good. We verified that our transformation was effective. Now, I'm going to go through and do the same for age, to where, because there were fewer than 5 individuals in a number of the different age ranges, we're going to basically create 2 age groups, where we have ages 21 to 25 and then 26 plus. Double check that, and that is correct. And then for gender, unfortunately, we're going to be getting rid of gender in the face-to-face class because only 2 persons identified as being male. And then the football question we're not doing anything with for right now. So now that we've made our corrections, basically what I want to do, I better run this actually. So now what we want to do is, SPSS gives us all kinds of interesting variables like the start date, end date, the IP address, recipient email, all kinds of stuff. We don't really need any of that. But what I do want to retain is this variable right here, ID. And then I want to retain all the MBI items, and then our 3 categories, categorical variables that we're retaining. So you can write code in SPSS where you're basically saying keep these variables. So we're going to run that now. And here, when we go back to our data set, we'll see, okay, we have our ID, we have all of our MBI items, and then we have race, age, and the football question. Great. Now this for our class, there's one more thing I did to create your Excel spreadsheet. And basically what I did was, for all the people that indicated prefer not to answer, what value Qualtrics assigned to that was an 8. Now, when we go through and do the mean scores for the 3 subscales, what we want to do is treat that 8 as a missing value, because we don't want that 8 to be included in our calculations of the mean or the total scores. And the way to do that in SPSS is through a recode, to where we're treating 1 as a 1, 2 as a 2 through 7, but then everything else as missing. And I'm going to do that now. And now at this point, what we would do is we would export this data as an Excel file. I'm going to put it right on my desktop. Oh, where is the desktop? Why am I not seeing it? Okay, now let's take a look and see if it's saved on my desktop. Yes. Okay, now we have a clean data sheet. Now, creating a table in Excel is fairly easy. Primarily what you want to do is you want to click and drag on the entire data set that you have, and then insert a table and indicate if your table has headers or variable names at the top, which ours does. You click OK, and there is our table. Very, very good. Now, why imposing a table is very important is because if you want to arrange or sort your data in any type of way, such as ascending order or descending order, basically what that's going to do is make sure that all of the data stays with the particular ID. So if we didn't have this table set and we sorted a specific column by ascending order, it would only make adjustments to that column. So imposing a data on our data structure is very, very important. And like I said, the way to do that is to click and insert a table with headers. Okay, and then because Excel doesn't have quite the same features as SPSS, it's important also to create a code book similar to what I have done here, which in a lot of ways mimics the variable view in the SPSS data file. Now, next week we're going to be learning how to compute means and total scores, and start with some basic introductory descriptive statistics in Excel. And I look forward to talking with you again during that video. Have a great night, everybody.